Hi, my name is Ellie, and today I'm going to be talking about the minimum spanning tree. Now, before we start, make sure to like this video and subscribe for more amazing content. So now, let's get on with this video. Suppose a new set of roads spanning 3 cities is to be constructed. There are 3 possible roads to choose from to build, and each of them has a different cost. So, what is the least cost needed to build the roads such that we can start from any city and travel to all other cities? Well, in this example, there are 3 cities and 3 possible roads to build, each with cost 2, 3, and 6. So that means that we need to build at least 2 roads to connect all 3 cities. The question is, which 2 roads will we pick to give us the smallest cost? Well, clearly, we will choose these 2 roads to build. That is because they have the minimum cost of 5. And put in coding terms, this is actually our minimum spanning tree. And that is basically just a tree that contains all of the original grass vertices and minimizes the total edge weight. Here's a more complex example. We want to find the minimum spanning tree of this graph, which just means we want to find a subtree in the graph that includes all of the nodes but has the least possible total edge cost. So I can start from any node, and I'll choose A, and I will insert it into my priority queue, which sorts by the distance from the current minimum spanning tree, or MST for short. So I will insert it, and the distance from the MST is 0 because the MST is non-existent currently. So since A is the only item in the priority queue, I can insert it into my minimum spanning tree list and also highlight it in my graph. Now we'll look at A's neighbors, which are B, C, and D. And since those haven't been added into the MST, I will add them into my priority queue. So B has a distance of 1 from the MST, C has a distance of 8, and D has a distance of 5. And now that A's neighbors have been added, I will cross it out from my priority queue. So since we're looking for the least possible total edge cost, it would make sense that we choose the node with the least distance from the MST, and that would be B. So I will add B into my minimum spanning tree list, and I will highlight it here, and we know that this edge has been chosen to be in the MST. So now we'll look at B's neighbors, which are A and E. A has already been added into the MST, but E hasn't. So I will add E into the priority queue, and it has a distance of 12. So now we can cross out B since its neighbors have been added, and we'll repeat the same process. Currently, D has the smallest distance from the MST, so I will include that in my minimum spanning tree list and highlight it in my graph. And now we'll look at D's neighbors, which are A, C, and E. A has already been added into the MST, so I'll look at C and E instead. So I'll add C, which has a distance of 3, and E, which has a distance of 4. So now I can remove D from my priority queue. So we'll repeat the same process. Currently C, this one right here, has the smallest distance from the MST, so I will include that in my minimum spanning tree list, as well as highlight it in my graph here. So now we'll look at C's neighbors, which are A, D, just A and D actually, and both of those have been added into the minimum spanning tree, so we don't have to do anything, and I'll just cross C out here. So now we'll repeat the same process. So currently in our priority queue, E here has the smallest distance from the MST. So I will add that again into my minimum spanning tree list, and I'll highlight that in my graph. And now we can see that all of the nodes have been highlighted, meaning they've all been added into the MST. So we've found our final MST. And we can calculate the minimum cost by summing the edge costs. So the edge connecting A and B has a cost of 1. The edge connecting A and D has a cost of 5. The edge connecting D and C has a cost of 3, and the edge connecting D and E has a cost of 4. So now we can see that our total cost will be 13. And everything highlighted in green here is our MST. So here's the pseudocode of the MST algorithm that I just presented. So we'll first have a priority queue that sorts by the distance from the current minimum spanning tree, and then we'll push in the starting node. And here's just a variable that keeps track of the total cost so far. And we'll have a while loop. So while not all of the nodes have been added into the minimum spanning tree, we will check the top node of the priority queue, and if that hasn't been added into the minimum spanning tree, then we will add it to the total cost, and we will also add it into the minimum spanning tree, and then we'll iterate through each of its neighbors. And if the neighbor hasn't been added into the minimum spanning tree, then we'll push that into the priority queue. And we'll just keep repeating that until all of the nodes have been added into the minimum spanning tree. And then at the end, we'll just output the total cost. Thank you so much for watching this video. I hope you enjoyed it. Make sure you press the like button and subscribe. Bye!